have this Ninja food processor, blender type deal where the Ninja. If you clicked on this video, you probably know what this is. So it stopped going. The motor stopped spinning the blender when you push down on the button. Now, it has a safety feature so that it doesn't activate without being on the blender's cup. And that is that little white peg down at the bottom. That's a safety switch, which gets pushed by a little peg on the receptacle on the cup. So that guarantees that this motor has to be sitting down in place. This gets pushed down right here, and once that gets pushed down, then you can push the button on the top. That is the signal when that little peg in the bottom over here, the safety switch gets pushed in. That tells the motor that this is sitting on the receptacle on the blender cup. That activates it and allows it to turn the motor on when you press down on the button. Well, that's not happening. So I want to get into this and see if I can make it work again. So I'm going to start with the simple stuff. Start with what I can see, and that's removing those two Phillips screws. Let's see if we can get into this and figure out why this is not working anymore. Right. I took both screws off. Let's pull this apart. It actually came apart easier than I thought. Let's take a look at this one. This is the button. So that's just a plunger going down. So not much to go wrong there. Let's see this now. Oh, there goes the screws. Okay, so that plunger pushes down on this. Yeah. So the switch assembly that gets triggered by both this little plunger, that safety switch, and the button from the top, the plunger that comes down, is this switch. This switch here, this right here, this little guy. This whole assembly here. Now I want to take that on because I want to test the switch. I want to test continuity from this leg to this leg by pushing down on that switch and seeing what the effect is of the other safety switch coming from the bottom is. So, but it's restricted. It won't come out. It's restricted height-wise. It just sits here in a slot. And that slot here, here and here. But it won't. It slides out to remove it, but it's limited in up travel by the rest of the motor assembly. So I'm going to remove the motor assembly from the rest of the housing, which so far it looks like it's mounted on these three rubber bushings, 1, 2, and 3. And this whole thing should slide off, and we'll get to the switch. Now looking at this, since I'm here looking at the brushes and the commutator here, that looks good. So my money is on this switch here. I have pulled the motor out, and it was just, like I said, those 3 screws. It took a bit of force to actually pull it up and out because of this rubber seal that goes into that hole. That's what to keep all the possible food or whatever from coming up, or moisture or water or whatever from splashing up into the motor. So it took a bit of force to get the motor to pry off of the housing. But it was just that. It was 3 screws and then a firm tug and it came up and out. Now we have access to the switch, and it's actually simpler than I was expecting it to be. This is the plunger that goes down into the safety switch that protrudes out of the bottom of this, and this is what gets pushed up by the action of setting the motor on top of the blender's cup. This is the little nipple that sticks out of the bottom. This is what gets pushed up. This is your safety switch. Now, I was expecting that to be another button just like this one on the switch, but it's not. It is literally the housing that the switch is mounted to. So when the motor, now remember, this switch here is the one that gets pushed on by that green plunger. This plunger, this all sits on top of that, and when you push down on this, that plunger comes down, and that plunger is the one that's activating this switch to turn the motor on. But it will only turn the motor on when this whole cup assembly is sitting down on the cup. Well, motor assembly is sitting down on the cup. The cup pushes this switch up. When it switches, normally when this thing is up and out of the blender cup, that switch is free to slide down and walk away from this green plunger, therefore disabling that switch. So when this is up and removed out of the blender, that switch will not be activated by that green plunger. Therefore the whole motor is deactivated. It's taken out of commission. But the action of setting this on top of the cup, the blender's cup, the rim on the cup pushes this switch up, allowing the green plunger to now reach that switch. So all this little safety switch is doing is this housing, like we noticed, like we saw over here, like we saw here, it is free to slide up and down. It is free to slide up and down over here, and all it's doing is that little plunger going through the housing and sticking out on the bottom right here. Like that. So when you put this thing on the blender's cup, it pushes the switch up, making it tall enough for the green plunger from here, for this to push down and activate and push on that switch. So there's nothing broken mechanically here, but it's still not working, so I think that switch is gone. Let's test that switch now. Two things to keep in mind, to set your mind at ease. The 3 screws that I took off from the motor to separate the motor from the housing are the same exact screws, same length, same type as the 2 screws that we removed in the beginning to split the whole housing apart. So no need to separate or keep track of the screws. I checked them out, they're the same length, so they'll go back in any position. The second thing is, the switch has a little spring, a little return spring. That little return spring, there's nothing retaining it in place, so it's easy to lose. Don't lose it, keep track of it. So now what I have here is the switch. I have it connected to a meter, and I'm testing continuity just to see if the electricity from the meter sending through one path will jump the switch once I press it. Once I close the circuit, once I close the switch, it shouldn't get through the switch and back to the meter, and the meter will beep. We'll get an audible signal to test continuity, to see if there's a continuous path between here and here when I close the switch. The switch is open now. That means that the blender would be in the off position. It's not running. But by me pressing the switch would be the equivalent of pressing this on the blender. And we should get an audible beep. Oh, it's trying. So as you can see, the switch has a dead spot. It still closes contact. It makes contact in a certain position. If I go slow, you'll see it makes contact there, but if I keep going past it, it stops. And it's supposed to make contact all the way down to the bottom of its range. And it's not. It gets to a point where it makes contact, and then if I keep going, it's dead. That is all the way down. That's where it's supposed to function. That's what it gets used, when it gets used. So yeah, the switch is bad. Check this out. This is good news. The switch is not even a sealed switch. Looking at it from here, I was expecting that switch to be a sealed unit. One that is not repairable and you have to buy a new one and replace it. But, looking at the back side, you can't probably see it, but all the contacts are open. The back of the switch, there's not even a housing on it. It's a purely mechanical thing that we have access to. So that means that we can slide the switch out of this plastic housing. We'll set that aside, and now we have access to the switch. Look at that. You know what this means is that we can clean those contacts. And now you can see, let's see if I can get this thing to focus. You can see the plunger as I'm pushing down on the switch. You can see the plunger coming down, making contact with a little tab on this side. And this side over here is worn. This tab is good. This tab over here, not so much. Let's see if I can get a little closer. The tab on this side is worn out. Let's see. Let's see if I can get this thing to focus. Okay. So this tab, you can see the copper has a little bit of an angle, a little bit of a ramp coming up this way, which is what the plunger rides on here. When I push down on the switch, this contact here touches that, and it's supposed to bridge the gap between this tab and this one over here. However, this one is worn out. So this is the one that stops making contact with this plunger over here. Alright, let's see if I can fix that somehow. Now you can see it a little better there. Alright, let's see if we can fix this. Here, this is let's see if I can get an even better view of why this thing doesn't work. I need a macro lens, something better than just my phone. Okay, so as the plunger comes up, as this plunger comes up, that cone shape, that's supposed to make contact with the far tab here and the one that's on the near side, which is no longer there. It wore off. But there's a certain point where it makes contact just about there, but if I keep going any deeper than that, it goes past it altogether. Can you see that? And it goes past it altogether and it stops making contact. That's why the switch is bad. Alright. I pulled out, as you can see here, I pulled out the plunger from inside the switch, and this is what the switch is made of. There's the little bell, the little plunger, which it looks nasty because it apparently was covered in some type of dielectric grease. But anyways, that little plunger, that little bell, And that is what bridges the contact between one little tab on one side and the other side of the switch. As it plunges up and down, it makes contact. It bridges that gap. Now, this one, it's just pressed on to a little plastic button that's spring loaded inside of the switch. This goes in here. And see, it goes in there and sticks out on this side. You can see it there. And then that little bell gets pressed on top of it. Now, I don't have a way to easily replace this little contact on this side. You can see how worn out it is. It's supposed to have that ramp just like this side, but this side is gone. I don't have a way to easily replace this because it's staked on here with the same plastic housing that gets mounted to hold the little tab in place. Once I cut off or drill away that little plastic, I can't replace it. I can't put anything back on. And plus, I don't have a little one of those tabs anyway. And I tried looking online, and I can't find a replacement switch for this. Like it's typical for modern equipment. There's the once it breaks, you're supposed to go out and buy a new one. So it looks like I'm gonna have to try to fix this switch because I can't find a replacement for it. But since I don't have one of these tabs, and I can't think of a way of making one easily enough, what I'm about to try to do, I do not recommend, but I'm gonna try it anyways. I'm taking this risk for myself. I'm gonna desolder the power wire from that. What's left of this contact, I'm gonna take the wire off of that, drill a little hole, see if I can mount the wire directly, mount this little wire directly onto this bell. So that means that this bell, instead of being the contact between that tab and that tab, taking the power from one to the other, this little bell is going to be connected to that wire. So now the bell itself going to have the power. It's going to close the contact, close the switch, therefore eliminating the need for that worn out tab. I'll see if that works. But now the reason I'm saying I don't recommend this is because I'm getting not into the replacement of components, which should be easily done. I'm getting into the modification of it. And this is deviating from the original design. Once you start doing that, you're taking matters into your own hands. I'm only showing you what I'm doing, just in an attempt to try and extend the life of this thing. We could easily go and buy a new one, but I like to tinker with things and to extend the life of it and fix it if I can. So, but from here on out, you're on your own. I don't even know if it's gonna work, but you're welcome to stick around and see if it works anyways. We have a hole. We poked a little hole in the little bell, which, by the way, appears to be soft. Well, it's pretty thin. Appears to be brass. So all I did, this is tiny by the way, all I did was get a straight pick. Can you focus on that? Okay. I got a straight pick. Got a straight pick. Put it down on the table. Push down. Pushed a little hole. Of course, that mushroomed out the hole on the outside. Left some sharp burrs, which we needed to take care of, so it didn't shave away or cut into the cable. So I got a little file, and I filed it back smooth. And there's the result. We have a hole. Now I'm gonna desolder the wire from here. Desolder the wire, run it through here, tie it up, solder it back on. If that is successful, then I'll come back and I'll take this contact away from here and assemble the whole thing back again. The wire is fed through the hole, twisted around itself, ready for soldering. Yeah, the wire is soldered up. Let's put this thing together, see if it works. In preparation for the reassembly of the switch, we need to take this tab off, the old broken tab off. So what I did was I drilled away, see the plastic rivet? And that holds the tab in place. I drilled the head of it or the tail of it off. Here, you can, since it's plastic, you can either drill it carefully or you can get a knife and just slice it off, cut it off. But either way, get that rivet off. That will allow you to take this tab off. So let me clean that up, and I'm going to assemble it with the new modification. I just realized the problem. I staked on, I pressed on the little bell back onto the plunger on the switch, and I just realized the problem. Which, by the way, the remaining tab over here, I had to temporarily bend that out of the way so that this bell could get past it and be pressed onto the plunger of the switch. But remember that spring that I said that is inside of this switch? Well, the plunger has a switch that makes it spring loaded in the off position. And that guarantees that whenever you take whenever you let go of the switch will spring away from making contact. If that spring is not there, remember this switch is lives vertical like this. So if there's not a spring inside of here, spring loading the switch to the off position, taking that bell away from the contacts, opening the contact and killing the electricity, killing the motor. If that spring is not there, there's a chance that just by gravity under its own weight, that bell, that plunger here will sit back down on the contacts and make contact, making the motor run continually, even if you take your finger off of the trigger, the switch. So it's important for that switch to be there. Now, having said that, I just realized something. By me soldering the wires onto, let me get a pointer. By me soldering the wires onto the bell directly here, that is limiting how far back into the housing that bell is retracting. Because the wire, the soldered bit of the wire over here is bottoming out on the housing. The switch moves it up and down in this way, but when it retracts to the off position, the limiting factor is not the end of the travel of the plunger. The limiting factor is the wire bottoming out on the plastic housing. Now that means that this bell is constantly under spring pressure to come off. The plunger on the switch still wants to keep going farther down this way, but it's not going any further because that bell over here is being held back by the wire. That means that there's a chance that the spring tension alone may cause that bell to come off of the plunger, disengage itself, and since this lives vertical like this, if that bell comes off, it's going to come down and make contact. Therefore, if that disengages, this is going to make contact even if you're not pressing the switch. That's a problem, so I need to remedy that. Alright, I have relieved a groove, a channel down here, in the place where the cable is going to live. So hopefully, I just had a Dremel. I got a Dremel and I ate away at the plastic to give it a channel for the cable to sit into. I'm going to reassemble this again and see if that bell bottoms out all the way down and the cable is not the limiting factor. And it still looks like that cable is making contact before that bell bottoms out. So let me eat a little more away from that. Done. There you go. That's better. Now let me squeeze the end of that bill so that it squeezes onto the plunger to give it a better chance of not coming off. And we should be ready to go back together and test this out. Okay. I bent the remaining tab back into place. And now this should make contact, close contact, or close contact, open contact with the plunger, with the switch. So should be working. After you get the switch in place, you got the motor sitting in place, back upside down. To help you line it up, these wires that come from the switch to the motor, or from the motor to the switch, either one, they're supposed to run down on either side of this plastic housing over here, on these little retainer clips. Get those cables. I hadn't taken them off just so that I could have more length of wire to play with the switch. When you're putting it back together, make sure you run them through there, and that's going to help you position the switch. There you go. Put the motor assembly onto the plastic housing, line up the 3 rubber bushings with the plastic receptacles over here, and then put the screws on. Done. Screws are in place. Get the housing. Slip it over. Obviously, line up the plunger, the switch with the plunger side over here. If you put it up backwards, I don't even think it would line up, but just in case. Oh, and don't forget that spring inside of here. It just free floats in there and get it sitting on top of the switch. After you line up and put the housing on, flip it over, and let's get the 2 screws that go in there. One there, one here, one here, one there, and we should be ready to test it. Okay, screws are on. And it's moment of truth. Let's try it with its base. Very good. It works. Now, just out of curiosity, you see this rim here? That rim is what triggers that safety switch. It serves to center and line up the motor, and as well as triggering that safety switch. That is what prevents you from triggering this off of its base. Success. Alright, it works, it lives. We got a little more use out of this thing before buying a new one. Alright, like always, I hope it helps you. I hope you find it useful. If not, at least a little entertaining. You get to look at the inside of one of these Ninja food processor blender deals. And yeah. See you next time.